This is the auto-dub version of Geneva Mechanism created by Assembly 4. Please select your preferred language for audio and subtitle. Let's see how it works. Create a new file. Switch to Parts Design. Create a new body. Create a new sketch on XY plane. Create a circle. (40 mm) radius. Draw a construction line. (30°). Another line. Tangent to the circle. Check the reference box. These two lines should be perpendicular. Also check the reference box. So, this is center to center distance. Make it 18 mm radius. Draw anther circle with construction line. These are the major dimensions of the driver and the drive. So, extrude the circle by 5 mm. Create a new sketch on XY plane. Draw a circle. (7.5 mm radius). Draw a stadium. (4 mm diameter). It is 23.09. Draw a circle. (36 mm diameter). This is 46.188. Cut the space. 5 mm. Use polar pattern. Repeat by 6. And this is the drive of the system. Create a new sketch on XY plane. Draw 2 circles. (25 mm), 32 mm. Change Z to 5. Cut the space. 2 mm. Apply chamfer. Switch to wireframe. Select top edges. Apply chamfer, 1 mm. Change the color to blue. Hide the wheel. Create a new body. Create a new sketch on XY plane. Draw a circle. 60 mm diameter. Extrude by 5 mm. Create a sketch on XY plane. Draw a circle. 4 mm diameter. (23.094 from the origin). Draw another circle. (36 mm). Draw a circle. 80 mm diameter. (46.188 from the center). Change Z to 5 mm. Extrude by 6 mm. Create a new sketch on XY plane. Draw a circle. Six millimeters. Cut the space. Reverse. Through all. Use all edges. Change the color to golden yellow. Change the pin color to dark brown. Switch to Assembly 4. Create a new assembly. So these parts are under part container. Create new coordinate system. Select the bottom circle. Concentric. Hide the disk. Show the wheel. Create new coordinate system. Select the bottom circle. Concentric. Create a new body. Create a new sketch. Use default LCS. Draw a circle. 15 millimeters diameter. Extrude it by 5 millimeters. Apply chamfer. Change the color to blue. Switch to Assembly 4. Create a new body. Create a new sketch. Use default LCS. Draw a circle. 6 millimeters. Extrude by 11 millimeters. Apply chamfer. Change the color to white. Go to Assembly 4. Create variable. Rotate. Set the value to 0. Create a new sketch. Use default LCS. Create a line. 40 millimeters. (46.188 from the origin). Draw another line from the origin. Snap to the line. 23.094 millimeters. Check reference box. Same for the other one. Check reference box. Move this line to show the mechanism. So, this is 30 degrees. Minus 30 degrees. When the driver line moves beyond 240 degrees, the line for the wheel is still moving. Delete the constraint. Set the angle as variable.rotate. Angle A and angle B are changing at different rate. This is the relationship between angle A and angle B. As the range of angle A is plus and minus 60 degrees, I use 180 minus variable.rotate as the angle B. Copy and paste the expression to this angle. Run the animation. From 120 to 240. So, the mechanism looks good. As angle B changes only in the range of 120 to 240. So, I set the conditional expression to limit the rotation of A. When the range is greater than 240, angle A will be set as minus 30. If it is smaller than 120, the angle is set at 30 degrees. Copy and paste the conditional expression to this angle. It looks good. Change the range from 0 to 360. So, the first line moves only within the range 120 to 240. Create new coordinate system. Select the line. Z tangent to edge. Set the variable to 120. Create new LCS. Select the line. Z tangent to edge. Insert component. Select the wheel. Parent assembly. Insert the disc, the driver. Change Y to -5. Change the angle to 30 to match the pin and the slot. Insert the center part. Hide the LCS. Hide the master sketch. Run the animation. If you find this video interesting, please subscribe and give it a like. Thank you for watching.